Hey ladies and gentlemen, this video is about congruence, and just one thing that other people have told me in the past that helps them when we get to this part of the chapter is to use different colors. I know I've said that a lot, but it really does help, especially when the triangles are not facing the same way like you see here. So if you do have different colors, just pause the video, go grab them really quick before we get started so that you have them. So we've already learned a little bit about the word congruent. We know what the symbol for congruent looks like. And we know that congruent means that two objects are the same shape and the same size. So that should be a little bit of review. So what we're going to focus on in this video is when we have two congruent figures, how to identify the individual corresponding parts of those figures that would also be congruent. Okay? So if two figures are congruent, then we know that all of the corresponding angles are congruent and the corresponding sides are congruent. And this word right here just means like the parts that match up, that are in the same position. So parts that are in the same position. And that's what I was talking about. It's really helpful to use different colors to show the parts that match up. So for example, I'm going to grab my highlighters here, and this congruency statement is telling me that if triangle ABC is congruent to triangle NMP, then we can figure out the individual parts that are the same. So for example, A is first in this congruency statement, N is first for this triangle. So I know that A and N are congruent. But sometimes when you look at your picture, it may not seem like they're in the same position. Right? So something that might also help you guys is just to think about these congruent figures in terms of transformations. When we learned about reflections, translations, and rotations, that might kind of help you, because I can kind of see, you know, these triangles look as though they've been reflected. And so now it makes a little bit more sense why A and N would match up. And then I would go to the next set of letters. So the next set of letters are B and M. So if I look at my picture, that means B has to be congruent to M. And then lastly, let's see if this will work. C and P are both last, which means angle C and angle P have to be congruent. So then when you write out your congruency statements, you want to write out the three angles that are congruent and the three sides are congruent. So I want to say angle A is congruent to angle N, right? Those are both, we put them in blue. Angle B is congruent to angle M. We put those in yellow. And then lastly, angle C is congruent to angle P. Now I want to do the same thing for the sides, which can be a little bit trickier, but you can still use the order of the letters in the congruency statement to help you out. For example, AB would match up with NN. And I still want to put my segment symbol like we did in the very first unit. Segment AB is congruent to segment NM. And I can do the same for the rest of the sides. So as I do this, I'm going to mark them. So A, B, and M, and I'm going to put with one tick mark. Then I'm going to do BC, because it's the second and the third letter, is congruent to MP. BC, MP. And when you mark them as you go, it's a little bit easier to see now the last ones that are left. So AC, which is the first and the last letter, has to be congruent to NP. And you can use that same strategy to mark up the angles as you go. I like to use the colors, but formally we know that arc marks show congruent angles. So I could put, we know, one arc for each of the blue angles, two arcs for each of the yellow angles, and then three for my red angles to show that they're congruent to one another, but not to all the other angles. So if a question asks you to list out all the corresponding parts, that's what I've done here. I've listed all of the congruent corresponding parts based on this congruency statement. The converse of congruent figures also is going to help us decide if two figures are congruent or if two figures are not congruent. And we know that the word converse means opposite, kind of. Like if we flip-flop the if-then. So if we don't know that the triangles are congruent, but we do know 3 corresponding angles are congruent and 3 corresponding sides are congruent, then we must know that the two triangles have to be congruent themselves. Okay? So here's an example of a diagram that may be given to you. I can match up 2 sides that have 1 tick mark, 2 sides that have 2 tick marks, a set of sides with 3 tick marks. And likewise, I can do the same thing with the angles. These have 1 arc, 2 arcs, 3 arcs. And so if I'm able to kind of go down the list, are there 3 sides that are marked congruent? Are there 3 angles that are marked congruent? If that's true, I can write a congruency statement. And when you write your congruency statement, order matters. This is very important. The way that I usually set up my congruency statement is to pick one triangle to start with. And we're going to use HGF. So the first triangle, it doesn't really matter how you write it. What's most important is that when you write the second triangle, you match up the corresponding parts. So for example, H. You can use your colors here to help you out if you need to. H, on this triangle, it has the 1 arc, and then on my other triangle, it's also H. So I know H is going to match up with H. That one was kind of easy. Right? Then G. So I find G. G has 2 arc marks. On my other triangle, I would need to find the angle that has 2 arc marks as well, which would be I. So I know that I has to come next. Can't really see that. And then once you get the first 2, then it becomes a little bit easier because, you know, F is the only one that's left, which must match up with J. And so if the colors help you out, feel free to use them. You're welcome to use them on a quiz or a test. And I think that it's, you know, once you get the hang of matching up the parts that go together, the congruency statement becomes a little bit easier. And again, if you need that little checklist, you're looking for 3 sides, 3 angles. If you only have, you know, 2 sides or only 2 angles, that's not enough. You need to have all 6 pieces of information right now. Third angles theorem is a theorem that will help us figure out that the last remaining angles must be congruent if we're given that 2 sets of angles are congruent. So here's a diagram in which A and G are marked congruent because they each have 1 arc, and B is congruent to F because those 2 angles have 2 arcs. So if you think back to our triangle sum theorem, we know that all 3 angles in a triangle must add up to be 180 degrees, right? So, for example, let's just say that this angle was 50 degrees and that this angle was 80 degrees. That means this is 50. That means this is 80. And so, if you have 2 sets of angles that are congruent, by default, the third angles have to be congruent, because if I added these up and subtracted them from 180, I would get 50 degrees, right? If I did the same thing over here, if I added these up and subtracted them from 180, I would also get 50 degrees. And so you can see that these angles are congruent, and that will happen every time. So you can make an if-then statement here. So if angle A is congruent to angle G, and angle B is congruent to angle F, then we know angle C must be congruent to angle E. And so you can use this reason when you're doing your proofs, or when you're solving for a missing angle, or when you're just trying to show that the last pairs of angles in a triangle are congruent, because if you know 2, then the third angles will always be congruent. Other important properties of congruent triangles that will show up often, the reflexive property. It's kind of self-explanatory, but yet it's really challenging at the same time because you need to be able to see it. The reflexive property just says that every triangle is congruent to itself, or every side is congruent to itself, or an angle is congruent to itself. And so if I gave you two triangles like this, ABC and ABD, that were connected to one another by this side, right? Even if that side has no tick marks at all, I know it has to be congruent to itself because it's overlapping itself, or it's the same segment contained in two different triangles. Same thing in this diagram, which is a little bit hard to see. So let's say I have this red triangle, and then I have this yellow triangle that are overlapping. They share a common angle, and the common angle that they share is angle A. Now, no matter what I do, I can even separate these triangles, but A is going to always be congruent to A because it is itself. So anytime you have an overlapping kind of a situation, you would want to use reflexive. Transitive we talked a little bit about already, and that's just multiple substitutions. If you can't remember this word, it's totally fine with me if you just want to write the word substitution, but here's an example in case you weren't there the day that we explained transitive property. Alright, here's two examples that you can go ahead and jot down. They do have to do with congruency statements. The first one is just asking you to list all the congruent corresponding parts if you know these two triangles are congruent. Number two is the converse. So it's giving you some information and it's asking you to determine if the two triangles are congruent. So remember, we're looking for three sides to be congruent and three angles to be congruent. So that might be something to write down as like a little checklist. SSS, AAA. So for number one, I'm going to list out three sides and three angles. And if the colors help you, feel free to do that. I like to go right in order. So I know S is congruent to D. Angle U is congruent to angle A. And then N and Y have to be congruent. Go ahead and pause the video and see if you can write out the congruency statements for the three sides. So right now we just did three angles. See if you can get the three sides. So go ahead and check how well you did. Just so you know, on this last one, you could also flip-flop the order of these segments. So if you said US is congruent to AD, that would be fine, as long as you match up the corresponding parts. And what I mean by that is, you know, S has to be in the same location as D. So if they're both first or they're both last, it doesn't matter, as long as they are in the same location. So example 2 says, determine if the two triangles are congruent. If so, write a congruency statement. So you want to go write down your checklist. We're looking for three sides, three angles. So right away, I see one tick mark, two, three tick marks. So I have all three sides. My angles, however, are not marked. So then you want to brainstorm and see if there's any reasons we've learned that might allow you to state that the angles are congruent. And so, for example, those two angles, I know they're going to be congruent because they're vertical angles. So I want to make a little note to myself. Vertical angles are congruent, so I'm allowed to do that. I also notice that these two sides are parallel. And we just had a quiz on parallel lines. We just learned so many theorems for parallel lines. And if it helps you to highlight these or extend them, you're welcome to do that. I noticed that this line cuts through both of them, and then I have that little Z shape. And so that reminds me of alternate interior angles, so I'm going to mark those congruent because alternate interior angles, if lines are parallel, Alternate interior angles are congruent. I could do the same thing for these other angles, right? I could use alternate interior angles again. Or, because you already have two, you can use third angle theorem. Okay, so that little brainstorming session is going to help you fill in the necessary information. So once you have SSS, AAA, I can now write my congruency statement. So yes, triangle XYZ is congruent to triangle. Remember to match up the order here. Order matters. So X, I chose X to be first, 2 arcs. So that would match up with U. Then Y would match up with T. And Z would match up with Z. And so this is my congruency statement. Basically, I'm answering this question by saying, yes, these are congruent, and these are the triangles that would be congruent. And the order does matter. Now, do you have to start with X? No. You could have started with Y. You could say YZX, and then your statement might look a little bit different, because instead of starting with X, you're starting with Y, then you would start with T. ZU. Right? As long as the corresponding parts match up. Okay, here's the last example before we try some proofs. And don't worry about the proofs, they're not so bad actually. The ones I'm going to give you in this video are pretty straightforward. They all have to do with matching up corresponding parts. So this question is asking me to find the value of X. And so I locate the angle that has X. And that is angle Q. I'm going to use blue just to kind of help me out right now. And I'm going to go to my congruency statement and figure out which angle matches up with Q. Because if I try to look at the picture, sometimes it's a little bit tricky. It looks like this angle might match up with M because they're both in the upper left, but remember, congruent figures are not going to be oriented the same way every time. Right now, it looks like this figure might be reflected. Looks like a little reflection to me. So I can't just match it up how it looks. I want to always use my statement. So if Q is first and L is first, that means 5x is equal to 122 degrees. So I could set up my equation. 5x equals 122, divide both sides by 5 to get my value for x, which I got 24.4. And you can check that by plugging it back in and seeing if it really does come out to be 122 degrees. Okay, proofs. Proofs with SSS AAA are pretty straightforward because you're going to do the same thing every time. You're going to go write down your checklist. Did I list out 3 sides? Did I list out 3 angles? If you did, then you're allowed to use SSS AAA as your reason. If you haven't listed all 6 pieces of information, then you cannot use this reason. Okay, so here's a given, and we're trying to prove that those 2 triangles are congruent. And so all I'm given is that this triangle is a multiple reflections of the first triangle. Okay? And so I put my given into my proof like I normally would, copy it exactly, and then we're going to work our way down the proof. So if you recall, the properties preserved under reflections. We talked about how angle measure stayed the same, and we talked about how distance stayed the same. Because even though you're reflecting a shape, you're not actually changing its side. And so those are the 2 reasons that we're going to use when doing these proofs. So for example, I'm going to list out all my corresponding angles. C is congruent to D, A is congruent to angle M, and lastly, R is congruent to angle B. And the reason why that is true is because this is a reflection, right? So angle, well, it's 2 reflections, really. Angle measure is preserved under reflections. And then, so if I go back to my checklist, I want to check my inventory. I have angle, angle, angle. I still need to list my sides. And so that is going to be my next statement. So CA is congruent to DM. AR congruent to MV. And then CR is congruent to DV. And then again, sides have to do with length, a distance. So when we reflect the shape, this side lengths do not change. So distance is preserved. Under reflections. Right, so now I have side, side, side. I check my inventory. We're good to go. So my last step is going to be what I'm trying to prove. Trying to prove that triangle CAR is congruent to triangle DMV. And that reason is SSS AAA. We're going to do some more proofs together when we come back to class. So just check and make sure that you've got your step-by-step. And then I'd like you to flip to your list of reasons because we do have some new things to add to our list of reasons. You can go ahead and add these new reasons that we learned in this video. So we learned a third angle theorem. Remember, that's when you already know two sets of congruent angles exist and you're just trying to show that the third angles exist that are congruent. Reflexive, that's when you've got an overlapping side or an overlapping angle, basically proving it's congruent to itself. Transitive, multiple substitutions, SSSAAA, that's what we use to prove that triangles are congruent. Find all three sides, all three angles are congruent. And then angle measure and distance are preserved. I did not write under reflections because it could also be under a rotation or under a translation. So I would just put under blank. And that's going to change depending on the context of the question.